All right, one of the big things I want you to understand is that in this nuclear business, you can't smell, you can't touch, you can't use any of your five senses for detecting radiation. We have other things that at the facilities that we measure: pressure, temperature, flow, and all those things are measurements. There's no such thing. When you take a measurement, you can't say, wow, I got exactly 32 ounces of pop at the convenience store. It's always 32-ounce cup and I didn't quite get it full, or you're just that really penny pincher and you got a little more than 32 ounces in that 32-ounce cup. I mean, you just don't, when you measure something, it's never exact. A measurement always is a measurement plus or minus some unknown error. And that's why we have to pull in statistics into measurements, is that what you basically have many times is, even if you take a lot of different measurements, one of the statistics models is the normal distribution or Gaussian model that says even if you take all kinds of different measurements and you have this average that comes right here down the middle, we can have some sort of average measurement. Let's say our average on this case was 30 what? 30 pressure, 30 temperature, 30 whatever you make it, that there was some error in all your measurements, and that was just an average. And the next time you take a measurement, it's not going to fall exactly on 30. You might next time get 31 or 32 or 28 and 29. And basically, this bell curve here has error in it, which we call plus or minus, we'll use the term standard deviation. And so if you go out from this curve, 1 sigma, which the small Greek letter sigma is our standard deviation, if you take that measurement plus or minus 1 sigma, that plus or minus 1 sigma takes up 68% of all the possible area underneath that curve. Okay, so it takes in 68% of all the possible answers you could have for the next measurement. So if you measured 30, you could be 68. The next measurement you take, if you took and said, okay, it's going to be 30 plus or minus 1 sigma, then you might say, all right, I'm 68% confident that the next measurement is going to come in within that range. And you can go out farther. You can go out to 2 sigma. If you go out to 2 sigma, statistics says on this bell curve that you'll get 2 sigma will give you 98% of all the possibilities. And then you go out 3 sigma. 3 sigma, I can't remember, 3 sigma is something like 97, and you get into 99% and all that sort of stuff. You'll never get 100% confidence. You can't say, my next measurement will definitely be such and such. But you can have a certain confidence level, and a lot of times in the nuclear business, we like to work with the 95% confidence level. We like to be 95% sure of what's the next thing that's going to happen. How's our measurement going to fall in the next time we take it? And so that's kind of what percent confidence means, is how close the next time we guess is the answer going to be to what we figured it was going to be, or to what is the right range of possibilities. So that wasn't the best explanation of percent confidence, but you've got an instructor that can work with you with the material and stuff and give you a good idea of how percent confidence works. But all I want to say at this point is saying something has plus or minus some error and not saying what your percent confidence is meaningless. For example, let's say right now, one of the things that is commonly done is every 4 years we have a presidential election. And they love to sit up there and talk about president number one they went and took a poll, and president number one has 40% of the vote, and president number two has 38% of the vote. and then they'll say, okay, this has a plus or minus error of 4 percentage points. And they don't ever tell you kind of what the percent confidence level is, because this error, how many percent error that has a lot to do with percent confidence. The more confident you can be in your measurement, the more error you're going to have in your measurement. If we go back to our normal distribution, and let me say that our average was 30, and let's say plus or minus 1 sigma on this thing happened to be a range of 25 to 35. So we know that if this measurement comes out 25 to 35, that's plus or minus 1 sigma. So we know that we can be 68% confident that it's going to be between 25 and 35. But somebody says, well, 68% confidence, that's not very good. You know, give me a better confidence. Give me a better idea that you're at least have a better idea what the real range is going to be. And so then you say, all right, well, I'll take it out to plus or minus 2 sigma, which we said 2 sigma brought in 95% of the confidence, or all the possibilities. Well, all of a sudden, if 1 sigma really here was equal to 5, right, because we had from 25 to 35, which is 30 plus or minus 5, now we got to take 2 times that 5. We got to take plus or minus 10 down here to get 2 sigma. So now your range turns out to be from 20 all the way up to 40. So you'd be telling this person, well, I'm 95% sure that my next measurement's going to be between 20 and 40, okay?